Previously, we have discussed OSPF, its LSA types, and stub areas. Looking at some diagrams, moving packets, and understanding concepts. Today, we will implement these concepts, and after this video, you will learn how to configure basic OSPF and stub areas. But wait, there's more. We'll also discuss verification commands, router ID selection, DR election, and common LSA types in the database. I know you're excited after hearing these terms, so let's go to the lab. First, let's discuss the topology. I'm using Packet Tracer for this simulation. There are 5 routers, all of it are 2811s with NM2FE2W modules. OSPF areas will be configured and the link between R4 and R5 will have static route to simulate external routing domain. Area 0, the backbone area, will cover interfaces on R1, R2, and R3. Area 1 have interfaces on R0 and R1, and Area 2 have interfaces on R3 and R4. R1 and R3 are area border routers since they have interfaces on both Area 0 and regular areas. R4 will be our autonomous system border router since it connects static route and OSPF. We'll redistribute static routes to OSPF in R4. IP address of links are shown in the diagram. Now let's start the configuration. Step 1. Configure OSPF process on routers and participating links with respective areas. This is done using these commands: router OSPF space process ID, network IP address, wildcard mask, area, and area ID. Note that wildcard mask is the reverse of subnet mask. For example, on this link we have 192.168.1.0/30 with 255.255.255.252 as subnet mask. The equivalent wildcard mask can be obtained by subtracting it from 255.255.255.255. Configuring on devices. Step 2. Add authentication for security. For a more secure approach, we will enable MD5 authentication in the whole area, then configure interfaces one by one. Here are the commands that we will use. To enable authentication in the area, we will use router OSPF, process ID, area ID, authentication, message digest. Then to configure authentication in the interface, we use interface ID, IP OSPF, message digest key ID, MD5, and password. Then IP OSPF authentication message digest. Configuring on routers. Now let's verify OSPF adjacency using showIP OSPF neighbor command. This command will show the following information: neighbor router ID, neighbor interface priority, state, dead interval timer, neighbor interface IP, local interface where neighbor has formed adjacency. We can also use the command showIP OSPF interface brief to check for interfaces running OSPF and its area ID. To verify authentication, use the commands showIP OSPF and showIP OSPF interface ID. Let's run these verification commands on other devices. Now, as you can see, router IDs are used by routers as their identity for OSPF. But how is router ID selected for each router? Router IDs are selected in this order. First is if router ID is manually configured. You can verify it by checking the OSPF process configuration in Show Run. Then, if there's no router ID configured, highest loopback interface IP will be used. If both router IDs and loopbacks are not configured, it would choose the highest IP address of a non-loopback interface. Looking at the output of Show IP OSPF in R0, you will see that the router ID is the IP address of the loopback interface, since there is no router ID configured. Then for R1, since there is no loopback, the router ID is the highest IP of a non-loopback interface, which is configured on Fast Ethernet 1.0. And R2 will use the router ID that is configured. Router ID is used to determine designated routers and backup designated routers in each multi-access network. In this case, each Ethernet link will have DRs and BDRs, since it's a broadcast network, which is a type of multi-access network. DR and BDRs are used to minimize LSA flooding in the area. DR is the central point of LSA exchange. All routers in the network sends LSAs to the DR, then it floods it to other routers. Designated routers are elected in this manner. First check is the highest OSPF priority. In case there is a tie, the next check would be the highest router ID. BDR will also be elected for backup. Once DR and BDR are elected, there is no preemption. This means that they don't change unless the DR fails. Let's have a quick look on R0 for DR and BDRs. In this lab, priorities are the same for both interfaces, so the tiebreaker is the router ID. R1 has a higher router ID, so it's elected as DR, then R0 as BDR. In R2, I'll configure higher OSPF priority on its interface, so that it will become a DR. We need to clear OSPF process since there is no preemption. Router IDs are also used in LSAs. We can check the LSAs in the database using the command show IP OSPF database. In our topology, we have type 1, type 2, and type 3, since we have backbone and regular areas. We'll see type 4 and type 5 once we redistribute static route in R4. Let's see what will happen after configuration. OSPF routes are also seen in the routing table. You can also verify using ping test. Now, if we want to reduce the database in a regular area, we can configure it as a stub area using the command area ID stub in the OSPF process. This is configured on all routers in the area. Let's configure area 1 as a stub area. After configuration, type 4 and type 5 LSAs are removed from the database, and a default route will be added in R0's routing table. Optimizing it further to remove other type 3 advertisements using totally stubby area configuration, using the command area ID stub no summary in the ABR. This time, inter-area routes are removed. All type 3 LSAs are replaced by default route. stub configuration can only be done in Area 1 since it does not have any external routing domain. For us to have stub area benefits in Area 2, we need to configure it as a not-so-stubby area. To configure NSSA, use the command area ID, NSSA on all routers in the area. After configuration, Type 5 routes will be converted to Type 7 inside the area. The ABR will convert it back to Type 5 when advertising to Area 0. Optimizing it further to remove other Type 3 advertisements using totally NSSA configuration. Configure ABR with area ID, NSSA no summary. That's a wrap for the OSPF configuration. If you want a copy of the packet tracer file, check the link in the description below. Like and subscribe for more networking videos. See you next time.